let's begin our discussion with the web and hypertext transfer protocol. So until the early 1990s, the internet was primarily used by researchers, academics, and university students to basically log into remote hosts or to transfer file from local host to remote host and vice versa, or to receive and send news or to send electronic mail. But then in the early 1990s, a major new application arrived on the scene. Yes, the World Wide Web. It was proposed by Berners-Lee in 1994. And the web was the first internet application that caught the general public's attention or eye. Right, so this web, application is basically it operates on demand. Means whenever a user you want to receive, you decide, and when you want to receive it. It's obviously pretty much unlike the traditional broadcast radio and television, which forces user to tune in when the content provider makes the content available, and it's very easy. Any individual can access the information or can make the information available on the web. Anyone can access it using navigating through the ocean of websites, and we use forms, JavaScripts, and many other development tools to make the web more interesting. And especially these web-based applications or web servers are being used as a platform for many killer applications emerging after 2003. For example, talk about YouTube, talk about Gmail or Facebook, right? So the basic platform these applications are making use of is the web, right? And the web is basically based on hypertext transfer protocol, HTTP, right? It's web's application layer protocol. What is HTTP basically? So this HTTP is the web's application layer protocol. Right, and its details are given in RFC 1945 and RFC 2616. So HTTP is basically implemented as in two programs. One runs on the client side, or we call it client program, and the other is called a server program, right? So the client program and server program, executes on different end machines. They communicate with each other to provide us the information to the user. So, before we go into the details, there are certain, a few concepts about the web that we quickly would like to look at. So first of all, in a web-based system, we have a web page, right? And this web page, basically, or a web page, basically, it's also called a document, right? It contains objects. Now, the next question is, what is an object in this scenario? So an object is simply an HTML file. Maybe these are JPEG images. These are some audio or video clips, right? That are addressable by a single URL, right? So the most web pages consist of a base HTML file, right? And which have several referenced objects. Okay, I mean we can access different objects that are on a base HTML file. So for example, if a base HTML file has 10 objects, then how many objects we will get from the URL, for example, this URL that is given here. If we have, we have www.someschool.edu/CS department, and there is a base HTML file and then 10 objects. So how many total objects are there? 11, right? So one object is base HTML file, and the other 10 objects, maybe these are some images, 10 images there that we can access. Okay, and then obviously, other than that, we also have a web browser. So a web browser such as Internet Explorer or Firefox or Safari, it implements the client side of the code, right? Or the client side of HTML or HTTP. Specifically, if we talk about it in the context of web, okay? And then we also have a web server. So web server basically implements the server side of HTTP. It houses of web objects, as we discussed, that are addressable by a URL. Okay. So HTTP is basically, if a client is running a specific browser and wants to access a URL, so it will send an HTTP request to the specific server, either it's an Apache server or Microsoft server, right? And in response, the client browser will get what? Will get requested objects and also the information that how to display these objects, right? Similarly, a client maybe is running on a mobile, right? So again, we can access a collection of web objects by providing a URL, and in response, we'll get what? All the objects. But before making this request here, first of all, this client has to establish a TCP connection here, right, between the server. Okay, so here we have to establish a TCP connection, right? So, for example, this client needs to provide the IP address of the server, right? And the port number of the port number for HTTP, which is 80, right? So, for example, if this web server has this address, I just assume 152.16.17.10 and 80. So using this, logical opening or a socket, I'll be able to create a TCP connection. And once the TCP connection has been established, right, then I can send HTTP request, and in response, I'll be able to receive what? I'll be able to receive the web objects, right? So HTTP is basically, it's stateless. Means the server maintains no information about the client request or the clients, right? On contrary, if we say that if server or HTTP is state oriented or it maintains state, so this means what will happen, that the server will maintain the past history of the client, right? What requests were generated, which specific URLs were visited, right? So if server client crashes, the view of the state may be inconsistent. So this is the problem with having HTTP state-oriented, that if a client is no more, or if a server has restarted or crashed, then the states won't be inconsistent. The information that was specific websites or URLs were accessed will be not consistent with each other, right? So as I mentioned earlier, that in order to initiate this request and response process, we need to establish what? The TCP connection first on port 80. Why? Because this port is reserved for hypertext transfer protocol, right? So when the connection is established, only then we'll be able to uh, exchange the information, right? So there are two types of there are two types of connections available using which we can transfer the data here, right? Either we can have a persistent HTTP connection or we can have a non-persistent HTTP connection. So when we say non-persistent HTTP connection, this means that we establish a TCP connection, and once we have transferred the requested objects to the client machine, the connection will be closed. And if you want to access another, base HTML file containing, any number of objects, web objects, then you have to establish another TCP connection, right? So for every subsequent request, we have to again establish a TCP connection, right? So this is called what? This is called a non-persistent HTTP connection, right? Where for every request, we have to establish the TCP connection first, right? But on the other hand, if we have a persistent HTTP, this means after the server, after sending the base HTML file and all the objects on that HTML file will not close the TCP connection between the client and the server, right? So the TCP client, the TCP connection between the client and the server is still there. So this means if I try to access try to navigate another link on the web page, I do not need to again create a TCP, connection. So this is called what? This is called, uh, you know, persistent HTTP. Now, this is another discussion that you can configure modern browsers to control the degree of parallelism, right? That is, for example, what do you think if I'm accessing a base HTML file that has 10 other objects? Will I be able to download all these objects in a single TCP connection? So I repeat my question. There is an HTML base HTML file, right? That has how many number of objects? 10 objects. What do you think? Uh, will I be able to transfer all these 11 objects, the base HTML file plus the 10 other objects, in a single TCP connection?
सर persistent HTTP में तो हो सकता है.
No, forget about the persistent. I'm just talking about what about non-persistent, for example?
No.
No. So this means I have to create 11 serial TCP connections. How many number of serial TCP connections?
11.
11. Right? But as I was discussing earlier, that a user can configure the modern browser to control the degree of parallelism. That is, that how many number of parallel TCP connections you can create to get the web objects from a specific web server, right? In the default mode, right, the modern browser can open up to it can open up to 5 to 10 parallel TCP connections. Okay, so that I'm talking about, the default mode, but obviously you can configure that how many, parallel connections you can uh, create, right? Okay, now let's try to understand what's the difference between a non-persistent HTTP connection and a persistent HTTP connection. So let's assume that I want to access a URL, www.someschool.edu/some department/home.index, and it has 10 JPEG images. What will happen first? So first of all, I need to establish a TCP connection. So the client side will request or will establish a TCP connection first. It will send a connection request first to the server, and server will acknowledge it, accepting its TCP connection request to establish a TCP connection at port 80. Um, the client at at step 2 acknowledges the acceptance of the TCP connection. Plus, it also sends an HTTP request message, obviously containing the URL. Okay, and what will happen in step 3? In step 3, the HTTP server will send HTTP response message containing all the requested objects into its socket. And now here, if it is a non-persistent connection, non-persistent HTTP connection, which it is, so what will happen? We will have 11 serial TCP connections. Okay. In one TCP connection, we'll send base HTML file, and then so on and so forth, right? And then by after sending the requested objects, the HTTP server closes the TCP connection. Okay, and on the client side, I'll take all the objects, I'll take the styling information given in the XML file, and I'll display the objects on the client machine. And now, if I want to navigate to another URL on the same web server, what I have to do is I again have to go through the step 1 to 5. Okay, means I have to again, establish a TCP connection, and then I have to get the requested object. So if I try to evaluate it in terms of the response time, so see what is happening here. So one RTT, by the way, this RTT stands for round trip time. This is what? Round trip time. This is the time taken by a small packet to go from this machine to the other machine, and then its response is received. Okay, this is known as round trip time. So one RTT is required to establish the initial TCP connection, right? So where we send a TCP request. So this is a TCP connection request. Okay, and server accepts it, right? So here is the acknowledgement from the server. The server has accepted the request, and this is what? This is one RTT, okay? And then the client machine acknowledging the acceptance of the request from the server, plus sending what? HTTP request message. Okay, and then what happens in response? The time that is required to complete this request is one RTT, that is to receive a response from the server here, plus you can see notice in this timeline, plus the objects that we have requested. I mean, how much time is required to receive this file depends upon what is the size of the objects that we want to receive. So if we ignore this, so fundamentally, how much time is required to get a response from the server in a non-persistent HTTP connection. So 2 RTTs there, right? So one for the initial TCP connection and 1 RTT for the HTTP request and response, plus the response time will be decided on the file, on the file size here, right? I mean, how many number of objects that we are, and what is the size of the object that is being sent from the server to the client, right? So this means every time I want to access another URL, I have to have this 2 RTT time is required to first establish a TCP connection and then to request a specific URL file. In contrast, if I try to look at the persistent HTTP, what is happening? So after sending the object or entertaining the request, server does not close the TCP connection. Right. So this means what? Again, we can generate the subsequent request. So what is happening here? So this means we can receive 1 RTT for all the referenced object, right? So for every reference object, I do not need to create a separate a TCP connection again. So if I look at the HTTP request, it contains basically 2 things. It contains a request line, and then it contains a header line. Every line is in this message or request is terminated with a carriage return and line feed here. You can see here, right? So the first line tells me the request, what sort of request it is. Either it's a get message, it's a get command, it's a post command, or it's a head command, right? And then we have the host, okay, URL, and then we have the user agent. Either I'm using Firefox or Safari or Internet Explorer and its version. Why it's important? Because certain web servers have different displaying information for, or the formatting information for the different web browsers. And then we have this, the language here. Either I want to see the information in English or in Urdu if it is available on the server, and then the coding information there. Okay. So what happens in response to this is that the server will send me the requested object, and we have different sort of methods there. For example, post, in which what we do, we can input the data in terms of in a form, right? Or input is uploaded on the server, or we can, we have this URL method using which we can upload something in the URL field, and for that we use what? We use